Hey everybody, so what we're going to do today is walk through how to work with the Python programming language. And we are going to just look at what that looks like in a very basic way um, before we even start to talk about what Python and ArcGIS would look like. And this is going to really help you work through Lab 5, where we will be asking you to take some data that we've provided and to use this very same tool to um, uh, manipulate uh, some data and to return certain results from it. Okay, so let's look at what we have here. I've loaded a website called repl.it, uh, which is an online Python compiler. Okay, so what that means is that this website takes in a Python script, compiles it, and processes it for you. Okay, and returns certain results over here, depending on what you program. And this is really useful because I don't want to ask you to download yet another piece of software. Usually we would process a Python script on our computer or in ArcMap even. Um, but luckily there is something that we can use online that actually compiles and works through our Python code for us. Okay, so you will be using this tool for Lab 5. And there is a link to it in the PowerPoint, and you can also Google it. It should be pretty easy to find. And we're also going to be working with some data that I have here. Okay, and so what I have here is some essentially geospatial data that is stored in a format that Python can understand. Okay, so it is stored in what we call the GeoJSON format. And that is, you can think of that as a kind of different kind of shapefile. A shapefile is a format for storing coordinate and attribute data. GeoJSON is very similar, but much more flat and something we would use for web mapping purposes. A lot easier in many ways to work with, and something that a lot of our programming languages can work with more easily than shapefiles. Okay, so it's a particular format for storing spatial and attribute data, and one that Python can understand very readily. Okay, so we have a dictionary here called Ontario that is storing data on 2 points in the province, Guelph and Elora. Okay, and I'm working here in a text editor, Sublime Text. Okay, and we want you to download or use one of these text editors for a couple parts of the Lab 5 assignment. Okay, so there is a little bit of software that we would like you to access. If you have a PC, you already have Notepad, and that will work. Otherwise, you can download Sublime Text for PC or Mac. There are many other text editors out there like Notepad++, Brackets. Unfortunately, for the purposes of this assignment, Microsoft Word is not a text editor. It does not preserve everything we need to preserve when we work with a Python script like this. It doesn't do a very good job of preserving formatting and other features. So please do not use Microsoft Word to open and edit this Python script. Instead, use a text editor. Okay, so what I'm going to do right now is just select all this and copy it and paste it into this online tool. Okay, and again, it just looks exactly the same as what I had it in the text editor. But now I can actually compile and run this script. Now, it's maybe not quite yet a script because I'm not telling the computer to do anything. I'm just telling the computer, here's my data. Here's my data on cities in Ontario. So if I go over here and click run, I'm not going to see anything change over here really. It kind of flashes and some kind of default stuff goes away, but I don't get any results over here in this window because, again, I haven't instructed the site, which is compiling my Python, to do anything. I've just said it, here's my data on cities in Ontario. But I can add another line here by pressing enter, and I can do something like print a statement to this window over here. So I can use the print function to do that. And as you'll see here, what's really nifty about this site, repl.it, is that it gives us some hints about how to use Python. Okay, so as I start typing out print, it suggests some things that I can do with it. Okay, and print is just going to be such a handy function built into the Python programming language for you to use to help you debug and understand what's going on with your script and data. So I'm going to print just something innocuous, hello world, and see what happens. Now I go back to the run button here. Now let's see what happens. Okay, it goes through line by line and compiles everything, but since this is just the data, it doesn't print it out again. Gets to here, line 33, and then line 34, it sees the print command and says, well, I better return that, print that out over here. And, I don't know how to spell, so, we'll just change that and run it again, and we'll get the right thing going here. Hello world. Okay. But what we actually want to do is to work with the data that we have and process it in different ways. We can ask several questions of it, like what cities in Ontario are border towns? What cities are within a certain set of coordinates? Okay, we can use the Python programming language to help us answer those questions about the data we have. So to do that, though, we need to start by understanding a little bit about the data we have. If we just look at it here, we can see that Ontario is a dictionary. Remember, these brackets indicate dictionaries comprised of features, a list of features. Remember, these kinds of brackets indicate lists. And we have two different features here. We have this first one, which if we look through it is Guelph. And this feature has some properties and it has a geometry. It is a point with coordinates of -80 and 43. And our second feature here in this list of features is Elora. Okay, and it is also a point, and these are its coordinates. Okay. So in a very basic sense, now we understand a little bit about what this data we have is. And so now we can, and of course you could have a lot more different points here stored in our list within our dictionary. Okay, but right now we just have two, Guelph and Elora. So now we can work with Python to process this data and understand it, ask questions, meaningful questions of it. So one thing we might start by doing is sort of subsetting our data and just working with the part that we need. We don't need this whole big thing called Ontario. Really, we're just interested in working with these features. So how do we access just those features? Well, we can use the syntax we have available in the Python programming language to do that. So we know that to access parts of a dictionary, we use syntax like this. Ontario, our dictionary, features. Well, let's see what that does. We run it. and it just gives us hello world. Now, why is that? It's because I didn't print this to the console over here. I need to print this over so that it shows up over here. Let's run it again. Goes through all this, compiles the data, prints hello world, and then it prints our list of 2 features, Guelph and Elora. Now I'm just going to go ahead and create a new variable called cities in Ontario to store this. So now I don't have to work with the whole big thing called Ontario, the whole big dictionary called Ontario anymore. I'm going to work with something called cities in Ontario. And this is just a way to kind of make it easier to work with things eventually. So I'll set this new variable, cities in Ontario, equal to Ontario features, and print that. And I should get the exact same output, and I do. Yep. So we might also be interested then in working with a specific part of a specific city in Ontario. We know that cities in Ontario is just a list of these 2 different cities. And so we can access parts of a list using a very similar kind of syntax, except we use numbers or integers to access parts of a list. So from the cities in Ontario list, we will access the city that is in the 0 position. Now this is something to pay attention to in the Python programming language. When we talk about lists of things, we start 0, 1, 2, so on and so forth. The first item in the list is actually at position 0. And just looking at the list, we know that that is Guelph. So we can say Guelph, create a variable called Guelph is equal to that first item in the cities in Ontario list, which is at position 0. So if we go ahead and print Guelph, we should see only the all the stuff about Guelph. Okay? So we run it, and indeed, that last thing we printed is only the information about Guelph, only that point. All well and good. But we might want to know a little bit more about Guelph. So we might print out, make sure it is Guelph. We can access the properties of this. Okay, remember that what we're looking at here itself is a dictionary, okay, because we have these kinds of brackets, these little curly brackets. So to access this key, or to access the properties, we use the key called properties. And let's just see what that looks like. The last thing that is printed out is just this another dictionary that is just the properties of Guelph. And we might then ask, of this dictionary, is Guelph a border? Or we might access that attribute, the attribute that describes whether Guelph is a border town. Okay. And what we're doing here when we create this kind of compound statement is saying, okay, from the Guelph dictionary, access the properties, and then access this key, this property, this attribute, which is whether Guelph is a border town or not. Okay, and so we could run that, and as we expect, it returns to us that piece of information here, which is that Guelph is not a border town, and that is false. Okay, and so we could do a bit more complex things with this. Now this is going to seem like a simple example because we are only working with this one piece of data, but bear with me. So let's say if we wanted to print something based on whether Guelph was a border town, or do something based on whether Guelph was a border town. We can use conditional logic, if and else statements to do that. So let's see what an if and else statement looks like. I'm going to go ahead and comment these out, these print statements, so that we don't have to keep seeing them over here. And we use the pound sign or hashtag just to stop. That's a way of telling Python ignore this. We can just write comments to ourselves. Everything on a line after a hashtag is completely ignored by Python. We'll keep this around for now, though. So let's take a look at what an if statement looks like. We start with the word if. We use parentheses to ask our question. In other words, to say if this is true. So if Guelph is a border town, so if this is true, and then we use the colon here to let Python know that if this is true, this is what it should do. If Guelph is a border town, if the result of this is true, we'll just print something to the screen. Guelph is a border town. We know that's not going to be true, so when we run this, we should see nothing happen. I mean, it will print this line, line 39, but nothing else. And as we can see, it prints false because it's printing line 39, but it doesn't print Guelph as a border town because we know that that's not actually what this data says. So we could add an else statement here. Else, and then again, using the colon to indicate, hey Python, we are letting you know that we're going to do something here. Else, print Guelph is not a border town. Before I run this, one thing to pay attention to here is indentation. Python is a little picky. It pays attention to spacing and indentation. Okay, so when you're debugging your script, you really want to pay attention to this. And luckily, this site is helping us keep things properly indented. Anytime we use a statement like if or else, we need to indent what comes after the colon. So if Guelph is a border town, colon, indentation, print this statement. Same thing with the else, colon, indentation, print Guelph is not a border town. So now we run this. I'm going to go ahead and first just cancel or comment out this statement. Whoop. This statement on line 39. Now we run this. Again, it's going to go through and process our data, and then it's going to, create some new variables just on basic out of the data we have here. Then it's going to get to these statements here, and it's going to process them. And based on what we know, it should return this statement. So let's see what happens. It says Guelph is not a border town. That's what we would expect. And we can be a little bit more precise here. We can say else if it's false, print this. And this is actually the way you would write this out is elif. Don't ask me why, this is just what they've created. They've kind of contracted the else if to elif. Now we run this, we'll get the same result. It's just a bit more of a precise way of writing this out. All right, Guelph is not a border town. because the answer here is false. The answer in our data is false. If we go to this feature, which we've called Guelph, or assigned the variable Guelph to, and we look at the properties here, and we look at this particular key, border town, this is what we get, false. Now, let's say we want to look at Elora. Now, we know that Elora is the second item in our list of cities in Ontario, and because we start from 0, it is going to be number 1. So Elora is cities in Ontario at position 1. It's the second item in the list, but we use the integer 1 to access the second item. Use the integer 2 to access the third item, so on and so forth. So we print Elora out. We should get all the details about Elora. So it still does the Guelph thing because we haven't commented that, but here we go. We've got Elora, which again is a dictionary, very similarly structured to Guelph. It has some properties like the name, whether it's a border town, and its geometry. So let's say we wanted to look a little bit more at the geometry here. After all, we do have geospatial data. Let's say we wanted to access the longitude of Elora. Print that out. So instead of going to the properties of Elora, we are going to go to the geometry. Okay, we are going to access and print out Elora's geometry. So we'll comment the whole Elora out and just look at what its geometry is. It is type point, and these are the coordinates. Okay, it's just a point, which we know, or a vertex, just two coordinates here, a longitude and a latitude. Now, usually we talk about latitude, longitude. In the GeoJSON format of storing coordinates, we start with longitude and then display latitude. Don't ask me why, it's just the standard that has been created. Longitude, latitude. And I should note this is just totally made up numbers here. The Guelph numbers are accurate, but Elora I just kind of fudged. So if we wanted to show the longitude, that's that first item in this list of coordinates. So how are we going to do that? We're going to print Elora geometry. And in particular, within the geometry, this coordinates key value pair. And we are going to access, well, let's just see what this looks like. We should just get this list back, right? And indeed we do. We just get a list of coordinates. And so, but we actually only want the first one, which again is at position 0. We want that first one because it is the longitude. And there it is. Just the longitude. Now, let's do an example, and this will be our final example, of going through both of our cities. So far we've just looked at one or the other at a time. Let's go through both of the cities we have. Okay, and you can imagine we could have 100 different points in our data set. We only have 2, but bear with me. If we had 100 different points in our data set, we wouldn't want to just sit here and type out, each one and figuring out things about each one. We would want to figure out a way to move through those 100 cities very quickly. And luckily, the Python programming language gives us tools to go through the different parts of our data very quickly. In particular, we can use the for operator to move through different parts of our data. So the way that this is this command is structured is we're going to say for each city, and here we're just creating a variable called city that is going to store each of our city's data as we move through the list or through the data that we have for all of Ontario. We're going to say for a city in cities in Ontario. Remember, cities in Ontario is just the list of features that we have, right? For each of those two cities in that list of all the cities, do something. Again, the colon always indicates do something. And again, after the colon, we need to indent, okay? And luckily it automatically does that for us. So what do we want it to do? Well, let's just print the city and see what that looks like. So I'm going to go ahead and comment out everything else we've seen so far, the other print statements, so that we can just focus on this example. So for each city in that list of two cities we have, print out the city. What do we get? Well, I didn't comment out everything I wanted to so far. We can leave that other one up, but let's run this again. So notice here we get, beyond just the Guelph is not a border town thing that we're still running, we get two results, right? Which makes sense. We have two cities in our cities in Ontario list of cities. And this first one is Guelph, and the second one is Elora. Now you can imagine, again, if we had a list of 100 cities in Ontario, Python would go through and print out each one. We only have two, so it's only printed two. But now we have a way of doing work on multiple things very easily. Okay, we can automate some things using this for loop. So yeah, maybe we'll print out the entire data, or maybe we will print out the name. And so we'll just do what we did up here. Remember when we accessed the properties of Guelph and whether it was a border town? Well, let's do that for each of our cities. Okay. So let's see what this looks like. We've created a loop whereby we go through each of those cities in the list, access the properties, access the name within that properties dictionary, and print it out. Guelph, Elora. Okay, makes sense. Now let's do something maybe a bit more geographical. Let's say we wanted to combine this loop with an if statement that allows us to ask questions of our data. Let's say we want to figure out something about, ask a question about the coordinates that we have. So we'll say if, again, we want these parentheses, if the city coordinate geometry and the coordinates within that, and in particular, let's say latitude this time. So remember that latitude was in the second position on that list of coordinates for each city, which means that it is at index 1. So if the latitude is greater than, let's just say 43.6, just kind of a made-up number based on what we've seen in our data so far, then let's say that's north enough to count as being part of the We the North. All right. So, if, it's so far north, and remember as we go north, the latitude increases, so if our coordinates are greater than this kind of arbitrary number, then we are going to print We the North. And so it doesn't print when we get through Guelph. It does print, though, after we get through Elora, because Elora's coordinates, it turns out, are, or its latitude is greater than 43.6. And we can, make this a bit more clear if we do, let's go ahead and comment this out. We can say print the city properties name, and we are going to use some syntax here to allow us to join together strings. So this little plus arrow allows us to join together different strings. Remember, strings are just everything that is included within a set of parentheses or quotation marks. So we'll say says this. So we're gonna, whatever city meets this criterion, that is its latitude being greater than 43.6, we're gonna print the city's name and say it says We the North. Exclamation. All right. So what we should expect here is Elora says We the North, because we know Elora is the only city with a latitude greater than 43.6. So we print it out, and Elora says We the North. Now, didn't get the formatting quite right. We're missing a space there. That's easily solved. We just put another space in this string. Run it again. Elora says We the North. And Guelph is still saying it's not a border town, right? So what we've done here is we've loaded in some geospatial data formatted in the GeoJSON format, consisting of dictionaries, these curly brackets here, in lists, a format that Python can recognize. We've loaded that in, and then we've created a script to process and work with that data in different meaningful ways. We've created code to ask whether the data indicates that Guelph is a border town, okay, and to print certain things based on whether it is or isn't. And we've also created a loop to go through each feature in our data, each city in our data, to assess its spatial location, that is the coordinates we have stored for it, and to print something based on that. So this has been a very basic introduction to how we work with Python, to give you a sense of what ArcGIS is doing when we load Python scripts into it. And again, you will be doing something very similar for assignment, for the Lab 5 assignment, where you will be getting data structured exactly like this, a few more cities, and we will be asking you to create a script to assess whether, to essentially clip the data down to just the cities that are south and west of Guelph, and also those that are border towns. Okay, so we provided you some of the tools in the Python programming language that will enable you to do that, such as if statements and for loops.